Okay, welcome to today's Finch Robot 2.0 Playground. So I'm Tom Lowers. I'm the founder and CEO of BirdBrain Technologies. And with me is Aparna Brown. Aparna, do you want to introduce yourself?
Yeah, hi, I'm Aparna. I know a lot of you. It's lovely to see so many familiar names and faces here. I am the Director of Operations at BirdBrain, and since we are a tiny company, that means I just do a little bit of everything. So you'll probably be receiving emails from me or, a number of other things that I'm involved with. And we are super excited that you're here today, super excited that the Finches are on their way, and we are really glad that we get to share them with you. So thank you so much for spending your afternoon, evening with us.
All right, thanks, Aparna. So today we're really going to be doing two kind of brand new things. We're going to be programming Finch Robot 2.0, which is about to start shipping to everybody who's ordered them or pre-ordered them. And we will have them kind of in stock in December, shipping to new orders at that time. So we're going to be playing with this new robot, and I want to do a brief introduction to talk through kind of the new features, the new capabilities of the Finch. And the way we're going to be playing with these is through remote robots. So remote robots is a technology that we developed at BirdBrain that kind of used some existing building blocks in the ecosystem to make it possible for you to program a robot from anywhere in the studio. So I'm here in the BirdBrain Technology studio, and I have several different camera angles showing the robots from different angles. So you can actually look through and see a Finch point of view, as well as kind of a view from my laptop. And you'll be using these views in conjunction with a programming interface that I will be sending you to program the robots. So let me start by telling you a little bit about the robot that you're going to program today, and then let me tell you about this remote robots idea, and then you can try it. This is meant to be about as hands-on a robotics workshop as you can get in a socially distanced virtual way. So it's a real, it almost seems like an oxymoron, but it works. All right, so let's talk about the Finch. The original Finch was developed at Carnegie Mellon University to bring computer science to life from kindergarten to college. And actually, the original Finch was really originally focused on the high school and college computer science end of that. Because if you remember 10 years ago, we weren't necessarily talking about coding in elementary school or middle school. But as the Finch became a commercial product, and then as it developed over the years, kind of grew in the 2010s, we added support for things like Snap, Scratch, so that you could program it with younger and younger students. That said, we kind of did that evolution with the same hardware that was developed way back in 2009. And so with the Finch Robot 2.0, what we were really able to do is kind of meet the original mission of the Finch, which is to be an engaging tool for computer science and now computational thinking education, and update the hardware to 2020 realities. I mean, if you think about, your electronics in 2009, 2010, the electronics in 2020, there's just a whole lot of new capabilities that we were able to use to make the robot even more engaging, even more exciting. I see that one of the robots has already started moving, so that's great. I think a few of you have been here before. Please feel free to go ahead and start programming. All right, so how do we support this kind of giant range of ages, right? We're talking about kindergartners who are 5 years old, who don't know how to read yet, up through college students, writing code in their, introduction to computer science with Java or Python courses. And so the way we do that is to take this low floor, high ceiling approach to give them different programming environments that are appropriate to different age and experience levels. So, as an example here, the top graphic is code or, a block script from Finch blocks that moves the Finch forward and back. This, again, would be appropriate for use with a 5-year-old. You don't need to know how to read. You're basically learning what an algorithm is by putting together sequences of actions. Down below, you can see the exact same code in Java. So it's going to, instantiate an object of the Finch, make it move forward, and then make it move backwards, and then disconnect from the Finch. So let me just take you through kind of a more granular progression of those programming environments. So on tablets and phones, again, you can start with Finch blocks. And Finch blocks actually has 3 different levels in it. So if you look closely at the graphic here versus the one before, you'll notice this graphic of Finch blocks doesn't have parameters. It doesn't have, it doesn't let you decide how many centimeters to move forward. But level 2 and level 3 actually do let you decide how many centimeters to move forward, how many degrees to turn, what light exactly to change your LED lights to, what color exactly. So we've got a couple of levels in Finch blocks. Then you can move to Bird blocks, which is a tablet app that we've developed at BirdBrain Technologies to work with the Finch robot or the Hummingbird robotics kit. That's really very Scratch-like, very puzzle blocks based, but really optimized for use on tablets with robots. And then once you move over to Chromebooks and computers, we have support for Snap, which is very Scratch-like. It lets you make, mixed animations and games with the robot, or use the sensors of the robot to control an animation or a game on the canvas. And then we also support MakeCode, which is the programming environment used or popularized by the BBC Microbit, which the Finch is also built around. And that is a beautiful environment because it actually has essentially a slider that lets you switch from blocks to text. So you can switch MakeCode into Python or into JavaScript. You can see what the code looks like. You can make changes in that text code, and you can even switch back and see what the corresponding blocks look like. So it's a 2-way bidirectional blocks to text system, which I think I'm not aware of any other environments that do that for physical computing or for robotics. And then, as I mentioned, you can program the Finch with Python. You can program it with Java. We are actually experimenting now with smartphone mounts. So this Finch, if you look at me in the corner, you can see there's a Finch with a smartphone mounted to it. Part of that is just because it's fun to put a phone on the Finch and see through its eyes. But the other part of that is for advanced high school students and college students, they could actually write their own apps, and that can get into computer vision, AI, machine learning, talk to your Finch and command it to move forward. So do voice commands, use the camera on the smartphone to track a ball or track an object. Those are things that we're now experimenting with and that we plan to release over the next year. In fact, we already have a basic API for programming for kind of making your own apps with the Finch. So yeah, we're really trying to support kind of every age, every experience level, so that everybody can benefit from using these, and so that if you're in a school district where you may have interest across a wide range of grade levels, you could imagine the high school students using them for a month, sending it to the middle school or the elementary school for an hour of code, or a 10-hour physical computing class, and then sending it back and forth in that way too. So in terms of what the Finch is capable of, the new Finch obviously still has wheels. It drives around. The nice thing about the wheels that we have on this Finch is that they have encoders, which means that it can move accurately. So now you can tell it to move forward, 10 centimeters, tell it to turn 90 degrees. And what that really means is that you can draw, shapes like triangles, squares, etc. And you can, it's good to be able to move accurately. It has an LED in the beak, which is similar to the old Finch, but it now also has 4 full color LEDs in the tail, kind of a strip of 4, and those are individually programmable and addressable. You can make them do rainbows, you can make them do animations. There's also an LED array in the BBC Microbit of 25 LEDs, red LEDs, that you can use to print characters, print strings, things like that. There is a buzzer, multi-tonal buzzer, so you can make like 8-bit music. There's a marker holder, and then there's a plastic brick adapter that you can use to, put your favorite plastic bricks on to build on top of the Finch and kind of customize it. In terms of sensors, there's now line tracking sensors. So that's new from the original Finch. So it can track a black line on white surface, or the alternate, or the inverse. It has a a distance sensor in the front that can detect objects up to about 200 centimeters, and it's fairly accurate. So it's really good at telling if it's about to bump into something. It has 2 light sensors, just like the original Finch, and then it has a compass, so you can tell it to drive north or west. It has an accelerometer, so it can tell kind of what its orientation is in space. And then it has 2 buttons on the microbit as well. So those are kind of the mixtures of outputs and inputs, and that mixture really allows you to do lots of really interesting activities. So a couple other things, one of the things we learned from 10 years of feedback is that the original Finch, the most common failure case was basically falling, not falling, it was being stepped on. And so we put some springs in the new Finch so that if you step on it, the pressure pushes the wheels in, kind of the wheels retract, and all the force goes into the shell, which can handle at least my weight, and probably more. It has a 7-hour battery. So the original Finch was tethered, which was actually really useful for classrooms that, if you wanted to use it all day, you could. So we wanted to retain that capability. And so we have a battery that lasts 7+ hours, 7 hours with it running all the time, like all the motors on, all the lights on. You can run it for 7 hours. And then, as I mentioned, we've got a lot of learning materials built around this. When we think about developing an educational product, we don't just think about the hardware or the software. We think about all of the activities that go with that, trying to align that with standards, but trying to also align it with, standard curriculum, like, the Python lessons follow a conceptual flow that is pretty common to an introductory computer science class. Same thing with the Java lessons. And then we also have recently released, in fact, they're live now on the website, professional development courses for block-based programming that kind of take you through programming the Finch, but also take you through how to use it to teach computational thinking. And that's all free. So all of that is free. When it comes to kind of additional things, the only things we charge for are live professional development. So if you wanted somebody to do, at this point, a virtual session, we do charge for that. But pre-recorded professional development, activities, curriculum, we provide for free, and it's easily accessible. So here's just a link to kind of the free learning materials for Snap. Snap is the programming language that is closest to what we're using. The remote robots environment is actually based in NetsBlocks, but NetsBlocks is essentially a clone of Snap that adds networking capabilities. So if you want that link there is clickable, and you can see kind of the programming activities and resources available for Snap. All right, so that's the Finch. So let me now talk about remote robots and kind of run through a little bit of an explanation of what the idea here is. So, so this was something that we developed at BirdBrain in the early days of the pandemic, in March and April. And it was done as a way of trying to help help teachers keep doing physical computing and robotics, even if their students were remote and if the students didn't have robots with them. So, the idea here is I'm in Pittsburgh, and I think the furthest person on the call today, Clara, is in Brazil, and she can program the robots. And so the idea is really just being able to program the robots from anywhere over the internet. And it's sort of honestly magical and surprising that this works. It's really, really cool. And not something that I necessarily expected would work back in March when we started developing it. So here's the idea of how this works. So we're going to send you a link where you will have a blocks interface for programming the robots. There'll be blocks in there like Finch move forward 10 centimeters or 50%. That sends a command over the internet to another project that's also in a blocks environment that's running on the laptops and computers here. And when that project receives the command from your project, and this whole transaction takes less than a second, it tells the Finch over Bluetooth to move forward. So 3 Finches or 3 Finch 2s can connect to one computer. This also works with the original Finch robot. It also works with the Hummingbird robotics kit, both the Hummingbird Bit, where you can do 3 to 1 computer, and the Hummingbird Duo, where you have to do 1 to 1 computer. So it's actually pretty cool. It works with all of the products that BirdBrain Technologies developed. And we have tutorials for how to make your own remote robot. I think that Aparna will put in the chat. All right, the other thing that's nice about this is the Finch's sensors actually also can be read over the internet. So over Bluetooth, you know, the Finch light sensor might be varying. It'll send that information over Bluetooth, and then the sensor data gets automatically sent to your project about twice a second. And so you know what that sensor data will be. You'll be able to read that light sensor. So what this really means is that these robots are now effectively Internet of Things objects. They are on the internet, you can control them, you can read their sensor data. So it's actually a nice little tutorial or an aside to tell kids, hey, you remember that Internet of Things thing? The robots are now Internet of Things things. They're things on the internet that you can control that are in the physical world somewhere. Okay, so let's talk through how to program the Finches, and then you guys can really start programming. So I'm going to click on this link, and Aparna will put the link in the chat. And so this is just a quick link that is, you know, a quick set of instructions for how to program the robots. So there's a big link to the Finches here. There are 6 Finches in the studio with me. And so I'm going to click on this link, and it's going to load up this project. Now, when it loads up this project, for me, it's almost like it's making a copy of the project. So everybody can click on this link at once. If I'm editing my project, that is not going to change your project. So you basically, as soon as you open this link, you kind of got your own private project for programming the Finches. To connect to a Finch, I would either hit the C key or this set of blocks here that says when C key pressed, connect to any robot. So it's going to then try to connect to a bunch of different robots. So A is already taken, B is already taken, C is available. So robot C is now available, and that's the one that I'm programming. If I want to try it out, I can click the green flag or click this set of blocks. This is just a little starter program. And so you can see it running. You can see, you know, program C running there. Sorry. No, not that one. That one. So there's robot C. That's the one I'm controlling. Robot B and A and E, I think, are being controlled by other people. So that's great. Let me switch back here. Okay. So I can control this. This is live. I can click on blocks. I can turn on the tail LED. I can make it beep. I can change my program so that it's doing different things. I can see what sensor data it's displaying by looking at, you know, the canvas over here. It's showing me the distance sensor reading in centimeters, the light sensor readings, the line sensor readings. So since there's more than 6 of you on the call, one thing that you can do is you can disconnect from the robot, and you can change the code even while you're disconnected. So you could create some new code, you know, and then you can reconnect to the robot, and you know, it'll take a second to find an available robot. C, D, E. Okay, they might all be taken already. Okay, so yeah, if nobody shows up, it'll show up like that. If you can reconnect to a robot, you know, you can then try your program again or run your program again. What I'm recommending, that since there's more than 6 of you, I recommend that you run the program, you know, assemble some code, and then disconnect while you're thinking through kind of your next move or the next thing that you're going to do. Put it together, put the program together, and then reconnect. by pressing the C key. And it may not be the same robot. If you want to control which robot you're connected to, you can put in the letter of the robot, A through F, by putting like a capital A in here or a capital B or so on. All right. If somebody is looking for a robot to, to program, please put that information in the chat. If you've recently made a robot available, maybe also put that in the chat. Like you might want to write into the chat, hey, robot C is now available. I've disconnected from it. And yeah, that's about it. So great question, Frank. There are 3 cameras in the studio. So there's the Finch point of view that's going to show you some things. There's a camera called Tom Lowers that will show you kind of a side view of the studio. But I'm also going to switch over now that my presentation is done. Actually, I'll do this in a second for real, but for now, this is going to be the main view, and I'm going to leave that on during the kind of the robot programming period. So you'll be able to see all the Finches from the top down also. But I just have a couple other things to mention. So, here's a quick, I just wanted to talk through this page a little bit more. Here's a quick set of instructions that basically mirror what I just said, a kind of useful orientation.
Patiently waiting with me on the line, please.
And then here's a description of the Finch snap blocks and some tutorials for programming the Finch in Snap. And then here's some suggested activities if you want to try out something that we suggest, like a dance robot, shapes, spirals, etc. And with that, I think I will switch to the overhead view. So again, please feel free to program the robots, try them out. Let me know, or let Aparna and I know if you have questions in the chat. This is kind of meant to be both an open playtime and an open Q&A. So if you've got a question, we'll try to answer it either in the chat or with audio. If you just want to program robots, that's absolutely fine too. So yeah, with that, Aparna, if you saw any questions that I should answer right now, let me know. Otherwise,
I'm sure they're coming now.
Yeah. All right.
I'm going to answer the question that we have been asked consistently for a long time, which is, when are the Finches coming? So the Finches are coming very soon. We're very excited to say. So we are hoping to have the first ones with USPS this weekend. So next week to be shipping them more en masse. So it is a great time to put your order in. And in fact, we have a few special gifts that we are giving people who pre-ordered. And so there still is a little bit of time to get in on that. And so I have a prototype of one of the gifts, which is the Finches that are pre-orders are going to come in a nice plastic case. They have a little foam insert that holds the Finch and a little channel in the back of the foam with a little hole so you can take your cord and plug it even when your Finch is snug in its box. After 2020, so once they start shipping in 2021, they will no longer come with this plastic case. And if you get your order in while it's still on pre-order. So until we ship all the pre-orders, this Finch is officially still going to be on pre-order for a few more weeks. We are also going to include a marker. So you can see Finch B has a marker in it. And there are a lot of really beautiful drawing possibilities with the Finch. So we're going to put in a marker with every Finch that is ordered on pre-order as well. So we definitely encourage you to order while it's still in pre-order.
Okay. So I saw a couple questions come in. Oops. Sorry.
Yep.
Around. So one question was about saving programs, and you can definitely save programs locally out of NetsBlocks. If you go to the file icon, there's actually 2 different ways you can do that. You can make a cloud account and save it to the cloud. Or you can do file icon and then export project, and that'll save a local XML file to wherever you want to save that. Another thing that's interesting about your question is you mentioned both computers and iPads. And so one thing that's important to note is with remote robots, the interface works for students who are remotely programming. It works on anything that has a browser. So, tablet will work just as well as any sort of computer. We do recommend the Chrome browser. It seems to work a little bit better than the others. But in general, it'll work with anything, any computer or iPad or other tablet. If you wanted to set up a remote robot at your own place, you would need to use a Windows computer, a MacBook, or a Chromebook. Okay. Now, there's another question about, are these finches available generally or just during the presentation? So these are just available during playgrounds. It's kind of hard to set up finches just to work kind of 24/7. However, with the Hummingbird robotics kits, I set up 5 of those back in March or early April at my house, and I have been trying to keep those running basically 24/7 using Nest Cams, and you can program those at any time. So Aparna just put the link in to the remote robots. So there's 5 robots there. I think they've had about 95% uptime. I mean, the things that seem to stop them are when Windows decides to update the laptop without me noticing, or when there's a thunderstorm and there's no electricity at the house. But the thing about the Hummingbird kits that makes it a little easier to put those up 24/7 is that they can easily be made into static displays. So they're not driving around an arena. They're robots that are stationary, where like a robotic creature where you can program the eyes to light up, the mouth to move, the wings to flap, things like that. So yeah, I would love to figure out a way to make the finches generally available like this, but at this point I haven't figured out a good way to do that. Another thing that's interesting to note is when we do this kind of programming over Zoom or any other video chat, it's very live. It's very much instantaneous. You click on a block, you pretty much see it happen. Even in Brazil, you probably see it happen in about a second. For the robots that I have at my house that are set up, they're using Nest cameras, and the advantage of that is that it's kind of an always-on live stream. The disadvantage is that live stream is delayed by 10 to 15 seconds, and that's just that's like a limitation of live stream technology. So there's sort of a difference between video chat, where they've optimized for having instantaneous two-way communication, versus live stream, where it's, you're just watching a stream of something, and in most cases you wouldn't care if it takes 10 seconds longer to get there. Although in this case, it would be nice if it was instantaneous. All right, seeing some good programs. Things are definitely progressing beyond the simple triangle. That's awesome. The triangle being what you draw if you just click the green flag on the kind of starter project. You see a square. Robot B is drawing a square. Robot A seems to be moving in, not sure exactly, but it was, oh, I like it. Yeah, so, Gonna go rescue Robot C. Sometimes they get a little bit off the screen. If anyone's waiting for a finch, please let me know, or if anybody is looking at them right now, and I believe they are all currently, somebody is connected to all of them. But one thing that I can do is if it looks like somebody's connected, but they're not moving, and they're not moving for a few minutes, I can manually go and break the connection so that somebody else can connect. E is definitely going. Or went for a second. Yep. Okay.
And if you guys belong to a group that you think would be interested in trying out these finches, so you belong to a CSTA group in your region or another group of educators or librarians or anything else, we would be happy to set up a Finch playground for you at a time that works better for your team. I mean, I know we have people from California, from Brazil, from all over the place, and we try to run these webinars at different times to catch people in different time zones. But we're definitely happy to share both remote robots and the new Finch robot with anyone you think would be interested. Like we mentioned before, we are a really small team. We are 7 people, and you know what has kept us going through this pandemic is all of the wonderful educators like yourselves that come to these things and learn and spread the word for us. So we really appreciate you being here, and we really appreciate you telling other educators about us. So please let us know how we can be helpful. Or like I said, if you think one of these intro webinar playgrounds would be helpful for a group that you belong to.
How long is a step when moving? So one thing I didn't say this time that I should have is if you look at the blocks in the movement category, the Finch blocks are actually at the bottom of that category, and they will have the word Finch in them. The move blocks at the top of the category, like move 10 steps, turn 15, I think, degrees, those actually affect the sprite on the canvas. So you'll want to use blocks that have the word Finch in them to move the Finch. And again, you'll find those at the bottom of the movement category. You'll also find the Finch LED blocks at the bottom of the looks category. You'll find the Finch sensors at the bottom of sensing, and the buzzer at the bottom of sound.
Great question, April. April asked if what the youngest recommended user is for the new Finch. So we have a programming language called Finch blocks, which at its lowest level does not require any reading or knowledge of numbers or anything else. So we say 5 because that's kindergarten. Unofficially, I'm pretty sure you could use it with kids that were younger. But yes, I was just going to say, Erin had her son using it. I couldn't remember exactly how old he was, so it definitely spans the whole K to 12 range easily. We have tested it out with pre-K kids and they seem to do fine. I don't think we officially recommend that, but.
No, we don't officially recommend it, but I definitely tested it with my 4-year-old nephew and my 4-year-old niece last year, and they were perfectly happy with Finch blocks level 1. Move these apart a little here. I'll do some Finch position management.
And if you have questions about Hummingbird or computer science in general or classroom integration, feel free, anything. Nothing in that realm is off limits.
So Heidi, your question about like the connection through the BirdBrain robot server. No, we haven't really had that problem. When you're connecting over Bluetooth, which is how we connect now to our new piece of software or to tablets or to computers, if the connection drops, it auto reconnects. And we've noticed about at least a 30-foot range. If you're in an open space, definitely at least 30 feet. If there are walls between you, then that's more of a problem. And we've also been fine testing at least hummingbirds in classrooms where you've got 10, 15 devices all connected over Bluetooth without hitting any congestion issues. And the finches are basically built on the same technology, so they shouldn't have the same, they should be the same. The problem with Scratch and the Finch, or like with having to reconnect often with the BirdBrain robot server, was actually the USB cable itself. Over time, the USB port on the Finch, we noticed that it would get a little bit flaky. And so you would have this situation where it might disconnect and reconnect often if that port had gotten flaky. So since the Finches don't use USB, the Finch 2, that problem basically gone.
Okay.
We have a question from Frank about iPads and bird blocks and storing files in the cloud so that a student could use any iPad. So they could store their file and come back to use a different iPad.
So we don't have kind of a native cloud storage solution there. Like you can't store it into some BirdBrain cloud or BirdBlocks cloud. But there is integration, I believe, with Google Drive and Dropbox. We have a tutorial on the website. I will look for it. That tells you kind of how to do it. So
I'll find it and put it in the chat.
Yeah. So like the saving and storing files in BirdBlocks, we actually have a tutorial about that. You can also email the files to one another. So if the email account is active on the iPad, you can email it from the iPad into another iPad.
Okay, so I guess I'm the late bird to the game. Sorry, I had an AP meeting. So they have that grant out for Computer Science Education Week. And basically for computer science honor societies to host something for at least 100 people on Computer Science Education Week. And from what I've been told, they're just throwing money at this grant so we can kind of do whatever we want. So I was wondering if we could potentially, whenever the Finch robots, Finch 2.0 robots get put out, if we could have something specific for saying, okay, we'll take your Finch robots and this is how we're going to go through, so you can share this link with others so they can control your robots that you'll have set up in your classroom or something like that during that week.
Yeah, I think it would be great to use these in some way to kind of create like cross-school collaborations. And I think, Eileen, you may have missed this because you came late, but we are starting to ship the Finches this week.
Oh, good.
We're going to try to get most of the pre-orders through before Thanksgiving.
Okay.
So by December, we should be in a regular kind of in-stock situation where you place an order and within a few days it ships, which is super exciting. Let me just say, considering how long it's taking.
Oh yeah.
Oh, I saw somebody ask about Robot B. I just reset Robot B, so I kind of disconnected and reconnected it on my end just in case there was a hiccup there. So I'm not sure if, Michael, if you were the one who reconnected to B or not, but but hopefully you were. So regarding the marker, we did not put in the kind of up-down capability. So you kind of have to manually put it in, and if you wanted to draw something where it goes up and down, you'd have to take it out and then put it back in. Robot B is the one with the marker, so it's the one with the green lights here, I guess. The reason we did not include the kind of marker up-down functionality was, honestly, it was a robustness concern. You know, if you build that in, and it seemed to me like a potential point of failure, like it could break often and easily, and it would also add significantly to the cost. So it was one of those things where, you know, in the end, it seemed like a better decision not to put it in. If anybody else is having connection problems or trying to figure out, you know, or doesn't have a robot and wants to connect to a specific robot, or just put that information in the chat. Oh, I think I just heard somebody have it play a song. Nice. Exploring the buzzer. Looks like robot E has an Earth is open. All right, yep, B is available now. Oop. D is pushing E somewhere. Don't know. Ooh.
Oh, that's a nice curve.
Yeah, I was thinking that too.
I see some letter drawing in that person's future.
Yeah, I think whoever's got robot B, I think has a, maybe they programmed like an arrow key driving program. Yeah, that was nice.
Getting kids to draw their names or draw the first letter of their names is always one of my favorite Finch activities.
Is there a way to tell on the interface which Finch you are connected to when it does say you're connected? Is there something that's missing?
Yeah, when you first connect in the sprite window, it'll say connected to robot, and then it'll give a letter. But there isn't something that is permanently there. So let me see if I can figure that out. because it is in the program. Let me think here. You know, I should add that as one of the things that you see. You know, you can see like that you're connected, true or false, but you don't necessarily see which one you're connected to. Yeah, I'm gonna try to add that in for next time.
Okay, because when it said I was connected, it didn't do anything, which I thought it was. I was controlling something, but nothing ever moved. And then when I thought it was moving, it was somebody else, even though it said I was connected.
Okay.
And what I saw was the letter B. That's why I said, could you move B? But
Yeah.
what it was doing on screen was not me. So I figured it out that it wasn't, I wasn't actually the one connected, even though it did report. I saw B as the last letter when it went true.
So B is now open. So if you try to connect, if you're like try to disconnect, I guess first. Oh, now B is taken. So they're all taken, but I'm gonna open up C because I haven't seen C move for a while.
Actually, I had the same problem when I tried to connect, and they said it was connected but didn't show the ladder. So I just turned everything off and restarted, and it worked.
Okay. Oh, that's, whoa.
Yeah, I had the same problem. I didn't know which one. I thought I made it move, but I wasn't sure if I did. And I just couldn't see how you do this with kids if I couldn't even figure out which one moved. So I don't know. I guess I'm still a little confused.
I think
How you do this with all those, and how do the kids know that they did it? Like, or do you only do one at a time? Or how do
yeah,
you?
I think we can. So this is a fairly easily solvable problem. We can make it possible for you to see which robot you connected to
Okay.
in the screen. So I will add that ability for next time because yeah, I think it seems very useful to know.
Tom, maybe a suggestion is like if you show your screen as programming, like to see how you actually view that letter, it might help. I don't know if you can share your screen. Next time, maybe just because yeah. Because later I understood that actually you see when you press, when I turned everything off and I backed and I pressed key C.
Yeah.
And then they came and it showed which one I was connected. First, none was, there we go. Yeah, because
real quick show when I hit C, it says trying to connect to Finch A, trying to connect to Finch B, and then trying to connect to Finch C. Oh, shoot, C is now in use. So it may actually, looks like all of them are in use. So let me kick off whoever was on A. Sorry about that, just so that I can show how that works. Or I'll kick off whoever was on C.
It was funny because I tried a couple times. It was like everyone I was using. I was like, nice. Everybody's having fun.
Now A is, so did you see it says connected to Finch A?
Yep.
Over here. And so now if I, click, it'll move Finch A. So I'm gonna disconnect now. And yeah, things are going kind of crazy. So you guys can see all that. So C and A are available right now. Okay, looks like somebody's taken A. But yeah, I will make it so that you can see the letter in the canvas at all times, so that it's much more obvious. So with that, there's about 2 or 3 minutes left of the playtime, and then I just want to wrap up with a minute or two. So if you are kind of do your last thing, I guess. I wanted to just give you that last 2-minute warning. So if there's something you want to try, now is the time. All right, we're gonna wrap this up. So thank you so much for spending some time learning about the finches, programming the finches. I hope it was fun for everybody. You can request a demo of the finch from this link. You can also see the slides. We did record this, so we'll send a recording out to you all. And at this point, as we've mentioned a couple times, they are here. We are getting out all the pre-orders, hopefully soon, and by December, we expect finches to be regularly available in stock items at our store. So yeah, if you've got any questions or comments, I'll turn off the recording now, and then you can just ask anything. You can stick around for a few minutes after that.
Thank you so much for joining us today. We can't wait to see what you make on social media. On Twitter, Instagram, and Facebook, you can tag @BirdBrainTech or #HummingbirdKit, or you can even tag me. If you have any questions, be sure to email us, info@birdbraintechnologies.com. We can answer questions about purchasing, about learning, about teaching, and about professional development. If you haven't been there yet, be sure to visit our Robotics at Home page. There you can purchase a kit for yourself, learn how to use it, and even join one of our upcoming webinars. Until we see you in class, thanks for watching from everyone at BirdBrain Technologies.